On your street, a steel beast slowly approaches with an unmistakable sound. It lifts a container with millimeter precision and swallows its contents with a deafening roar that wakes up half the neighborhood every morning. What you've just seen isn't just any truck passing in front of your house. It's a multi-million-dollar precision machine specifically designed to devour, compress, and transform tons of waste. But the inevitable question that nobody asks is what really happens inside its metallic guts when those doors close. And why is it so much more than just an ordinary transport truck? Today, we're going to completely open up its hidden world, and you'll be surprised by what you discover in the next few minutes. Let's start by breaking down the main types of garbage trucks that currently exist in cities around the world. Both because for every specific urban challenge, there is a completely different and highly specialized one of these steel monsters. In the narrowest residential neighborhoods with tight streets where a single vehicle can barely fit, the classic rear loaders appear. There, human strength still directly joins hydraulic power in a perfectly coordinated dance that requires years of experience. Workers toss bags inside, while a massive compactor plate brutally pushes and crushes the waste into the vehicle's main chamber, mercilessly shredding everything in its path. In modern neighborhoods with planned urban infrastructure, the scene changes radically. Automated side loaders completely dominate the street with almost German-like efficiency. An articulated mechanical arm extends its metal claws. It lifts the standardized several hundred-pound container and empties it completely in a matter of seconds without anyone needing to get out of the comfortable, climate-controlled cab. It's pure industrial automation in constant motion. In large-scale, high-density urban areas, the front-loading giants come into play. True titans of the asphalt capable of lifting enormous commercial containers of up to 8 cubic meters over the driver's cab and swallowing them whole in a single fluid and powerful movement that seems to defy gravity. But the technological variety doesn't even remotely end there. We're just getting started. On active construction or demolition sites of old buildings, where debris is counted literally in tons and not in simple plastic household bags, the high-capacity roll-off trucks reign supreme. Yet these giants don't seek to compress anything at all, but rather to transport entire industrial containers from one place to another. They haul away entire containers that can weigh up to 20 tons, leave them on site for weeks or even months, and return to pick them up when they are completely full of rubble, wood, metal, and concrete. And in European cities with strict legally mandated recycling rules, the split compartment trucks appear. True mobile organizers on wheels that separate the trash from the very moment of collection on the street. They have 2, 3, or even 4 separate internal compartments for glass, paper, plastic, and organics. Each of these trucks is a completely different character in the same epic story, the daily, tireless battle against the millions of tons of human waste we generate without a second thought. A modern garbage truck can cost between $200,000 and $500,000 US, depending on its built-in technology and load capacity. Fully automated side loader models with robotic arms cost up to 40% more than traditional manual rear loaders, but they dramatically reduce long-term labor costs by 60% because they only require one driver. It's a massive investment that cities must carefully calculate before purchasing an entire fleet. Now let's go directly inside the mechanical beast to see what secrets it holds. Most of these trucks share the same beating heart. An absolutely brutal hydraulic compactor that turns chaotic and messy garbage into dense, compact, and perfectly ordered blocks as if they were industrial bricks. The process begins in the hopper. The space where the first load of the day falls when the truck starts its route. At first glance, it looks like any unimportant metal receptacle, but it's the antechamber to one of the most brutal forces in all of modern urban engineering, designed by humans. A gigantic hydraulic piston drives a reinforced steel blade that violently pushes the waste into the main body of the truck with a force that could bend a metal beam. More garbage continuously enters during the route. The blade automatically retracts and pushes again and again without rest until it forms a compact wall of waste that occupies the least amount of physical space possible inside the compartment. Some late-model European models use advanced tilting blades. Others use high-tech sliding panels. And there are even American systems that use enormous augers that spin like colossal screws, simultaneously shredding and pushing in a mesmerizing continuous motion. The end result is always exactly the same, regardless of the system used. an incredibly dense mass so tightly packed that it literally looks like an artificial rock straight out of a compression factory. Imagine the colossal force involved in this process. We're talking about up to 30,000 pounds of constant pressure concentrated in a small area. Solid wood splinters without offering any resistance. Corrugated cardboard becomes as thin as tissue paper, and light metal fold as if it were common kitchen aluminum foil. This mechanical violence isn't gratuitous or excessive for show. It's the only effective way to turn urban chaos into a compact and economically viable block that justifies its transportation. The hydraulic compactor of an average truck generates enough pressure to crush a small car, literally reducing it to half its original size in less than 5 minutes. In fact, some specialized scrap metal trucks use the exact same hydraulic technology to compact entire vehicles before sending them to an industrial smelter. It's literally the same destructive force used in industrial scrapyards all over the world. Why all this complex technological and energetic effort? Because inside a garbage truck, every available cubic inch has a concrete and measurable economic value. It's not just about limited physical space, it's directly about operational efficiency and real money coming in or out of municipal coffers. The more material it manages to transport in a single complete route, the fewer trips it will have to make throughout the day, the less expensive diesel fuel it will consume, and the more streets it can cover before needing to unload at the transfer station. Compacted garbage is actually a compressed business in constant motion through the city streets. Inside the sealed chamber, nothing is still or static for long. Under the constant pressure of the compactor, the waste stratifies into horizontal layers that arrange themselves like perfectly stacked internal walls, one on top of the other. In some modern trucks equipped with advanced technology, smart moving panels continue to push the garbage backward, brutally squeezing it against the hermetically sealed rear doors. Everything is meticulously calculated by engineers specializing in fluid mechanics and material strength. State-of-the-art digital sensors constantly measure internal density and pressure in real time, alerting the operator in the cab when the structural limit is dangerously close. And when that critical limit is surpassed, there is absolutely no room for human error. The entire hydraulic system could collapse, causing thousands of dollars in repairs, or provoke a dangerous leak of toxic material that would contaminate the streets, because what's inside isn't just innocent plastic and clean office paper. Among the compacted waste, there is actively decomposing organic matter that releases extremely foul-smelling liquids technically called leachate, a corrosive enemy capable of wearing down the most resistant metal in a matter of months if not controlled. A single truck can generate up to 100 liters, about 26 gallons, of toxic leachate in a full day of continuous operation. That's why trucks are mandatorily designed with specialized drainage channels that collect this poisonous liquid, with industrial-grade anti-corrosive coatings that protect the internal metal walls, and with hermetic rubber seals that contain the nauseating odors so the city isn't literally flooded with them during the journey. Leachate isn't just unpleasant filth. It's a serious chemical engineering challenge that requires constant control and preventive maintenance every few weeks. Because in some European cities, this toxic liquid is treated as Class 2 hazardous waste and must be processed in specialized plants before it can be discarded into the municipal sewage system or nearby rivers. The inside of a modern truck is also a sophisticated electronic surveillance system comparable to that of a bank. High-definition internal cameras allow the operator to detect in real time if someone is illegally trying to dispose of items prohibited by municipal law. Electronic devices with mercury batteries, compressed gas tanks, lithium batteries from electric vehicles. All of these are potential dangers that can cause devastating explosions, uncontrollable fires, or total mechanical blockages of the compaction system. Thanks to these surveillance cameras, drivers can immediately stop the operation before it turns into an urban catastrophe with fatalities. Safety is an absolute obsession in these potentially deadly machines. The destructive power of a hydraulic compactor doesn't distinguish between inert garbage and a living person inside. That's why trucks mandatorily include emergency stop systems, both inside and outside the loading hopper, dead man controls that require constant human pressure to function correctly, and advanced ultrasonic sensors that detect the presence of pedestrians or nearby workers in the immediate danger zone. Some late-model European models even incorporate automatic fire suppression systems ready to activate instantly if accumulated flammable gases or crushed batteries ignite a spark inside the pressurized chamber. Yet its safety technology comparable to that of chemical industrial plants or oil refineries. Every year, approximately 12 sanitation workers die in the United States due to accidents directly related to hydraulic compactors. It's one of the most dangerous jobs in the country, with a mortality rate 6 times higher than that of the average office worker. That's why the industry invests millions of dollars annually in safety technology and mandatory training programs. And when the truck is finally completely full to its maximum structural capacity, the crucial moment arrives to unload all the cargo accumulated over hours. The journey leads to transfer stations, enormous industrial facilities where each load is meticulously weighed on 100-ton scales, electronically registered in municipal databases, and transferred to larger transport vehicles for the final journey. There, the rear door opens dramatically with a high-pressure hydraulic system, and a massive internal plate pushes the compact block of garbage out as if it were a giant brick of human waste. Specialized personnel carefully inspect the newly expelled mountain, manually separate hazardous or potentially recyclable materials using protective gear, and decide its final destination according to current environmental regulations. Some waste inevitably ends up in modern sanitary landfills where it is buried in layers and hermetically sealed with clay and plastic. Others travel to high-tech incinerators that convert the heat from controlled combustion into electrical energy for the municipal grid. And another significant portion goes to recycling plants where glass, plastic, and metal are chemically reborn as new manufactured products. In countries like Sweden, more than 99% of generated household waste is reused, completely recycled, or used to generate renewable electrical energy. There, the garbage truck doesn't represent a hopeless end, but the crucial first step of an infinite renewed cycle. Sweden even imports garbage from other European countries like Norway and Italy because its incinerators are so efficient that they don't have enough domestic material to generate all the energy their cities need. They literally pay for foreign garbage. A modern garbage truck can collect waste from up to 1,000 homes in a single 8-hour shift of continuous work. That means each truck processes approximately 3 tons of garbage per hour in continuous, non-stop operation. Yet in a city like New York, more than 2,000 garbage trucks operate daily to keep the streets clean, which generates more than 6,000 tons of processed garbage every workday. The world's most technologically advanced garbage trucks are currently being tested in Singapore and Japan. These vehicles are completely autonomous, drive themselves on pre-programmed routes using military-grade GPS, use artificial intelligence to optimize routes based on real-time traffic, and have robotic arms that identify and empty containers without any human intervention. It is the inevitable future of urban waste collection. The characteristic sound a garbage truck makes, that annoying backup beeper, was invented in 1964 by an industrial safety company, and since 1976 it has been required by law in most developed countries. Yet that annoying sound that wakes us up has saved thousands of lives by alerting pedestrians to heavy vehicles moving in reverse. The average garbage truck travels approximately 40,000 kilometers, about 25,000 miles annually, which is equivalent to circling the Earth's equator once a year. And due to the constant starting and stopping at each collection point, the diesel engine suffers wear equivalent to that of a vehicle that had traveled twice that distance on the highway. That's why preventive maintenance for these vehicles costs more than $20,000 annually per unit. The tires on a garbage truck are specifically designed to withstand uneven weight and constant lateral movement. Each tire costs approximately $500 and must be replaced every 2 years due to extreme wear. A complete truck has 6 wheels, which means $3,000 just in tires every replacement cycle. A garbage truck's fuel consumption is astronomical compared to a normal car. It consumes approximately 50 liters of diesel for every 100 kilometers traveled, about 4.7 miles per gallon, 5 times more than a normal cargo truck due to the constant weight and continuous starting and stopping. In 1 year, a single truck can consume more than 20,000 liters, over 5,000 gallons of fuel. The useful life of a well-maintained garbage truck is approximately 10 to 12 years before it needs to be completely replaced. After that period, the wear on the hydraulic system, chassis and engine is so severe that repairs cost more than buying a new vehicle. Yes, a garbage truck driver needs a special Class B commercial driver's license in most countries, similar to what bus drivers require. They must pass rigorous medical exams every year and quarterly safety training. The average salary for an experienced driver can exceed $40,000 annually in developed countries, and in cities like San Francisco, it can reach up to $70,000 due to the high demand and hazardous nature of the job. During the COVID-19 pandemic, garbage trucks were considered critical essential services. In many cities, collection workers received priority vaccinations along with medical personnel because if they stopped operating, cities would become massive infection hotbeds in a matter of days. In New York, when there was a threat of a strike, the mayor declared a state of public health emergency. And here's something very few people know. Garbage trucks also play a crucial role in urban security. In many cities, drivers are trained to report suspicious activity, abandoned vehicles, or emergency situations because they travel every city street multiple times a week. They are the silent eyes and ears of police departments. In some American cities, they even carry license plate recognition cameras that help locate stolen vehicles. Technology doesn't stand still either. There are already prototypes of electric garbage trucks operating in cities like Los Angeles, Amsterdam, and Shenzhen, China. These vehicles are completely silent, emit no polluting gases, and have operating cost up to 60% lower than diesel models. The only challenge is the battery range, because a garbage truck works for 8 continuous hours, and current batteries only allow for 5 hours of operation before needing a recharge. So the next time you hear the unmistakable sound of a garbage truck early in the morning, remember that it's not just a vehicle picking up smelly bags. It's a steel beast equipped with 30,000-pound hydraulic muscles, state-of-the-art intelligent sensors, and engineering solutions designed to face one of modern humanity's greatest challenges: how to efficiently manage the millions of tons of waste we generate every day without a second thought. Inside that seemingly simple metal box hide tons of hydraulic pressure, stratified layers of compacted garbage, and an industrial process that combines brute force with advanced 21st century technology. And although it goes completely unnoticed in our daily lives, it is one of the most sophisticated pieces of modern urban machinery. So, did you really know what these steel giants were hiding inside? Do you think garbage trucks are just unimportant heavy machinery, or an impressive example of how engineering and innovation move billions of dollars in the global waste industry? Share your point of view in the comments and subscribe to Creators Club, where every story reveals hidden opportunities behind the technology and businesses that move the world without us even noticing.